guys, and welcome to another video. So we are continuing with learning how to find our empirical formula. So yeah, let's get right into it. Before we go there, I just want to go back to the definition of empirical formula. I want to annoy you with it until it sticks in your heads. We said the way in which you define empirical formula is by saying that it is the simplest whole number ratio of atoms in a compound. Okay, now that we're done with that, let's get into our questions. Here the instruction says we have to determine the empirical formula of the compounds with the following percentage compositions by mass. So that's what you're gonna do. The first one we are going to look at is A. And as you can see, guys, I've already drawn my table. That's what you must do as well. But your columns will be guided by the number of atoms you have. Okay, and yeah, let's go and answer this question. And remember, I said that in terms of the first row or this first column, what we are going to have initially here is I'm changing my pen size. We'll have E here for our element, and then here we will have M for our mass, and mass is measured in grams. And then on the third row we are going to have N, which is our number of moles, and these are measured in moles. And last but not least, we'll have our ratio. Okay, so that's what we do firstly on our table, and then the second thing we do is to fill in these blocks, the ones at the top on the element row. And in this case, because I'm starting with A, I will have Fe, which is ion. Let me just fix my Fe. I will have Fe, which is my ion. So it's gonna be Fe. Then I will also have S, which is my sulfur. Once I'm done with that, I'm sorted, because in this case, although I have 3 columns, I'm having 2 elements here. Okay, 2 elements. So let's now start our work of finding the empirical formula of Fe and S. We go to the second row. On the second row, what are we going to do? We are going to write our percentages. Remember that these percentages actually represent our mass. And this 63.5% can also be written as 63.5 grams. If you were to find that situation, you would still write that value down here where there is mass. So let's do that. For Fe, we have 63.5 grams. I have quite an ugly 5. And then for sulfur, we are going to have 36.5 grams. Then we are done. Once we are done, now we'll move on to the next step, which is to find our number of moles. All right, so we'll say for the number of moles of iron, we have 63 divided by 5, and 63.5 divided by the molar mass of iron, which is 56. Where do we get our molar mass for iron? We get it from the periodic table. And then here we will have our answer. Then move this side. On the side of sulfur, we'll have 36.5 divided by the molar mass of sulfur, which according to my timetable, a periodic table, oh my word, periodic table, guys, it's going to be 32. And from here, we are now gonna use our calculator to get the answer. Okay, so when I say 63.5 divided by 56, the value I get is 1.3. Okay, it's actually 1.13. Yeah, if I decide to round off to 2 decimal places, this is what I'll have, 1.13. But remember, I said you can round off to 3 decimal places even. It won't be a problem. But let's stick to rounding off to 2 for now. Yeah, let's work with 2 decimal places. So that's the value I get. Now we'll move on to this one. Okay, for this one, when I say 36,5 divided by 32, the value I get here is 1,14 moles. Okay, that's what I'm going to have. Then once I've found my two values here, which are my number of moles, I will look for the one that is the smallest. Okay, the one that is the smallest between the two values. Which one is the smallest between this one and this one? Well, the smallest would be this one. Let me just write S here for small. This one is the smallest. Okay, that is the one that is the smallest. So what do we do with the smallest number of moles? What we are going to do is divide by that number on both these numbers, this one and also this one. So we'll start this side by saying 1,13 divided by this very same number, since it's the smallest, 1,13, and the value we get here should be 1. Then this side will say 1,14 divided by 1,13, and the answer we are going to get is 1,13 divided by 1,13. Yeah, 1,14 divided by 1,13 is going to give me 1,00, which essentially is 1, right? Once I have that now, because remember I said I must have a whole number. A whole number meaning that it's a number that is not supposed to be a decimal. I will come to my conclusion to say, okay, my ratio in this case is 1:1. And then these values here, or those values of my ratios, I will write here at the bottom. Say here it's 1 and here it's also 1. After that, what am I gonna do? I'm gonna come to my conclusion to say that therefore my empirical formula is these symbols with these numbers. But since my numbers in this case, my ratio is 1 and 1, I'm not gonna write the ones. I'm only gonna write the symbols as they are. So I'm gonna say therefore my empirical formula is FES, and that's the answer that I'm supposed to give there. So that's it for A. We are going to move on now to B. Okay, now we are moving on to B. For B, this is what we have. We have 57.5% of Na, 40% of O, and 2.5% of H. This is hydrogen, oxygen, and sodium. All right, and then the first step on our table, remember you obviously have to start by drawing the table, but since I'm trying to do things in a quick way, I've already drawn my table. So my table will have the first row, which is the row of my atoms or elements, that being N, A. Then I move on to the other one, which is oxygen, and the second one, or rather the third one, is going to be hydrogen. That's what I'm going to have. Okay, so once we are done with filling in our first row, we are going to move on to the second row. Okay, this is the second row, and on the second row we are going to write these percentages but as masses. So initially we'll have 57.5%, or rather grams of sodium. Then we'll have 40 grams of oxygen, and last but not least we'll have 2.5 grams of hydrogen. After here, what do we do, guys? We find the number of moles by filling in this third row. The number of moles is found by saying the mass of our atom divided by its molar mass. So we'll see here 57.5 divided by the molar mass of sodium is going to be 23. Yes, 23. Get the answer. Then here we'll say 40 divided by 16 for oxygen, find the answer, and then here we'll say 2,5 divided by the molar mass of hydrogen, which is 1. Okay, this one is easy because anything you divide by 1 remains itself, so the answer there is going to be 2,1. Let's calculate for these two. So when we say 57,5 divided by 23, the value we get is 2,5. Now we'll move on to this one, 40 divided by 16. And the value we get here is also going to be 2,5. After here, we now move on to our last row, which is the row of the ratio. How do we find the ratio? We'll look for the smallest numbers out of these three, our number of moles, and take the one that is the smallest, divide every number here, every number by that small value. So this is what we are using in case you are lost. These are the numbers that we are going to divide by the smallest number. Okay, and our smallest number in this case is what? 2,1. So we are going to say 2,5 divided by 2,1. Get the answer. 2,5 divided by 2,1. Get the answer. And here we'll do the very same thing. 2,1 divided by 2,1. This one is quite easy, right? Same numbers dividing each other will give us 1. Let's check what the calculator will give here. Okay, when I press the calculator, the value I get is 1,19. Since I'm rounding off to 2 decimal places, even this side I have 1,19. Okay, 1,19 on both these two. From here, remember I said that we are rounding off to a whole number, and a whole number is a number that is not supposed to have a ratio. How do we do that? We look at the number after this comma, which is this. If that number is bigger than 5, it's 5. Yeah, let me refresh. So we look at the number after this comma, and if that number is a 5 or bigger than 5, then we'll make this one a 2. Okay, same thing this side. We look at the number after the comma. If that number is a 5 or more than 5, then we'll change this one into a 2. But in this case, we can see that the number that comes after the comma is a 1. It's a number that is less than 5. So we are only gonna take this number before the comma without changing it, right? So that means our ratio in this case would simply be 1:1, because even here we can see that the number after the comma is less than 5, so we should not change this one after the comma. We take it as it is, which is that one. Then this one will take as it is as well, because it's already a 1. After writing 1:1:1, what do? We go back to our first row, write our numbers here at the bottom. Then when we conclude, we'll say therefore our empirical formula is these symbols here. I'll have NA. Remember, if the number is a 1 at the bottom, we do not write it. So I'll have NaOH. That is my empirical formula. What is the name of this, I wonder? Please find out for me and let me know in the comments section. Okay, let's move on now to the last one, C. Let's see how C is supposed to be solved. Alright guys, so now we are on C. For C, what do? We focus firstly on the first row, and on the first row we are going to list our elements, and those are your Na, sodium, C, carbon, and O for oxygen. So we'll have NaCO. After that, what do? Move on to the second row. On the second row, we are going to put our percentages, which are our masses, right? So we'll have 43,4, I bet 43,4, and we'll have 11,3 grams, and we'll have 45,3 grams. Once we are done here, what are we going to do? We'll use these masses to find our number of moles using the molar masses of these atoms there. So we'll say 43,4 divided by the molar mass of sodium, which is 23. Get the answer. Then here we'll say 11,3 divided by the molar mass of carbon, which is 12. Get the answer. And here we'll see 45,3 divided by the molar mass of oxygen, which is 16. Then from there we'll have our answers. Okay, let's find our answers. Okay, so when I go to my calculator and say 43,4 divided by 23, I get 1,88. Here when I say 11,3 divided by 12, I get 0,94. And here when I say 45,3 divided by 16, I get 2,83. What do I do after here? What I'm going to do is take, or rather look for the smallest value out of these answers that I've just found, and that value will be divided by all, or rather that value will let me rephrase English, guys. That answer will divide all of these other values. Okay, so here I'm gonna say 1,88 divided by the smallest number, which is 0,94. 0,94 is equal to, we get the answer there. Then here I'm gonna say 0,94 divided by 0,94. Get the answer, which in this case is obvious. It's going to be 1. Then here I will have 2,83 divided by 2,83, and I will find that answer there. Okay, I had already done this one. Okay, guys, I just made a mistake here. I'm sorry. I'm realizing that I'm supposed to write 0,94. Yeah, not 2,83. Please make sure that you don't make that mistake, because we are dividing by the smallest number, which is 0,94. When we divide these two numbers, they give me 3,01. And then when I divide 1,88 by 0,94, according to my calculator, I'm getting a 2. Let me just go do it again to verify. 1,88 divided by 0,94 gives me 2. Okay, once I have that, now I'm gonna put down my ratios to say, okay, my ratios are going to be 2:1:2. Here I look at the number after the comma and I can see it's less than 3, so I ignore all of these numbers, take this one as it is, and that is going to be 3. And then I'll take these numbers, write them at the bottom of my symbols. So I'll have 2 there, 1 here, and 3 here. Once I have this, what am I gonna do? I'm gonna write all of these as they are by concluding to say that therefore my empirical formula is Na2CO3. What is the name of this, guys? Na2CO3. Please give me the name of this compound in the comments section. Not gonna say anything for now. I want you to answer that question for me. I hope you enjoyed this video and found it to be valuable. If not, please just scroll back. Okay, what am I saying? I do hope that you found it valuable, and if you didn't understand anything, simply scroll back. Okay, and yeah, likewise, please like the video, guys, share it if you can, and also subscribe to the channel if you have not. Happy learning, and see you on the next one.